revision 17 discussion. Once the revision 17 discussion is done, we'll go for revision 18. And revision 18, 19, and 20 will be on paper 2 full papers, right? The challenge that I have is how to discuss that. The reason is if we take when we take the time for the writing the paper, it takes like 1 hour and 45 minutes. So usually did all the papers only for 1 hour, right? But we have to practice. I can't ask you to go and do it and bring it. The reason that the momentum is not there. Again, the ignore the distractions ready. Therefore, I want you guys to do the paper here. Is that clear? But anyhow, I'll find a way, right? We'll think creatively and finish the discussion productively as well, and also to have the paper discussed, right? Both ways. All right. So this is another type of question that we didn't do such questions earlier. It's a metal carbonate, any metal carbonate, disregard of any type of solubility thing. Any metal carbonate is going to react with acids, right? To give you carbon dioxide, salt, and water, right? But anyhow, how do we know, right? It is copper 2 carbonate. In order to understand, you should know that the blue solutions are coming from copper ions in our syllabus, right? Blue solution, there is no other solution is blue, like other than copper 2 ions. So then we can guess this should be copper 2 carbonate, and this should be carbon dioxide. And you put magnesium, you know that copper 2 ions react with magnesium due to the reactivity. You're not here to write only the answers shown on the board, right? I mean, the mark scheme answers. You must write the discussion. Due to the reactivity series, magnesium is more reactive than copper. Therefore, it can get displaced by magnesium. So the colorless solution, obviously, magnesium is non-transition. It is non-transition element. That's why it is giving you the colorless solution, right? And pink solid is copper solid. So you must have the ability to analyze the question and take the observation into account and come to a conclusion on this particular species. Okay. So identify the name and which, and then colorless gas, carbon dioxide. I think I explained everything. And sodium hydroxide, of course, it's going to be copper 2 hydroxide. Now, the special thing is identify by name, not from the formula. So coppers, this 2 is important in almost all the answers. Copper 2. Why do we have to write copper 2? Because it's a transition element. You need to put 2. All right. So 1 or 2 minutes. Quickly finish up writing this. Online students, kindly put your videos on and join the class. Pauli and Methuki, I can't see you. Okay, right. Students at the back of the class. One more time for it. Okay. Okay, right, let's go. Question number 2, periodic table. Describe another difference in the chemical properties of group 1 and metals. They have given one difference already. Reacts with water, then trans elements do not react with cold water at normal temperatures, right? But there are many differences you can write, especially the catalytic property is shown by transition elements, right? transition elements, metals show catalytic properties, but group 1 cannot show it. And group 1 have metals have fixed oxidation states, but these metals have variable valencies or variable oxidation states. Right? Describe the observation when potassium is added to water. Those are straightforward one. Will give you hydrogen gas bubbles, lilac flame, right? Then sodium doesn't catch fire immediately, but potassium does, right? And it will melt into a spherical ball, right? And it moves, flows. You can write down, not only your answer, you can write down all this stuff. And so, right. The equation is potassium reacts with water, giving you potassium hydroxide and hydrogen gas. On the balancing numbers, you put 2 in front of all. Colored compounds, formation of colored compounds. It's not anyway rejected, but when you say formation of colored compounds, like, okay, it sounds like chemical property, but a color is what? Color is a physical property. It's like something like density and all. With so color is a all right. The statements give some of the chemical properties of cobalt and compounds, right? And cobalt doesn't react with cold water. So let's go to our reactivity series: potassium, sodium, coherent reactivity series. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, copper, silver, gold. Right? Out of them, these are the 3 metals react, gives you rapid reactions with water. Rapid reaction with cold water. Right? What about magnesium? It's very slow reaction and no apparent reaction. No apparent reaction with water. Cobalt doesn't react with cold water. That means cobalt cannot be above magnesium. Why? From aluminium downwards, no reaction with water. The cobalt in node, the magnesium has to be something below. Right? So then cobalt has to be something below over here. It has to be here. Right? It freezes slowly with dilute hydrochloric acid. So from the water statement, cobalt is here. Now we'll take dilute hydrochloric acid statement. Now we'll take this statement. Slowly reacts it. You know that these ones, no reactions with acids. No reactions with acid. No reactions with dilute acids. Dilute acids. Giving hydrogen. Hydrogen hadanda bad. No reaction. These can't react because they are below hydrogen. So from the second statement, you can say cobalt should be not like from carbon to argon. Gold. It should be between zinc to what? Lead. Now we get it more confined, right? Then cobalt doesn't react with aqueous zinc nitrate. Cobalt doesn't react with zinc nitrate means cobalt can't displace zinc. Cobalt can't displace zinc means cobalt has to be below where? Zinc, right? If cobalt can displace zinc from zinc nitrate, that means cobalt should be above. Then bang, yeah, taking the I notice zinc pulp. Now from the third point, cobalt has to be between these fellows, right? Cobalt reacts with aqueous silver nitrate. Of course, it is above silver, we have already found, right? Cobalt oxide reacts with magnesium to give cobalt. That's quite understood. The reason is magnesium is way above cobalt, right? It's way above cobalt. Cobalt 2 oxide, COO, reacts with magnesium to give cobalt plus magnesium oxide. So that's understood. Now we'll put them in the order, right? Magnesium is above, it is more reactive, and sodium is the most reactive. You know that. And cobalt can't displace zinc. Therefore, zinc should be above cobalt, and the least reactive should be what? Silver. Least reactive should be silver. Can you see how we can come to the conclusion of what? Reactivity. It is kind of unfair, it's only 1 mark. So they are expecting you to understand the reactivity level fast, right? Okay, so let me give you a few minutes to finish. All right, Mithun, can you see the one? Or shall I reshare? I'll reshare once. If you don't see it again, you can quickly leave and join the class. It might work in that way. Petuka, German, Metum, Mauli, I can't see. All right.
Sir, I sent you a message.
Right. Okay, so let's go ahead. What are the factors that determine the position of elements in the periodic table? Right, 2 marks. Definitely atomic number. Atomic number. Why? It is a rule. What's the rule? The periodicity is due to the atomic number. Elements are arranged in the periodic table according to atomic number. It's a rule, right? And also, group number is equal to the number of electrons in the outer shell. Group number. This is from group number. Group number. And this is the period number. Number of electron shells. Right? Deduce electron configuration of phosphorus, phosphide ion. You should not do it straight away. Phosphide ion. So don't do like that. First of all, you look at the phosphorus, which is 2, 8, 5. And then phosphide 3 minus means it needs 3 electrons. Needs 3. Therefore, it takes 3 and it will turn into 288. Do it with the understanding. And phosphorus, last shell, you have 5 electrons. So it has 5 electrons and it needs 3. Therefore, it is going to share 3 with a non-metal atom. right? Thereby, you put anyway, you know that phosphorus has 3 hydrogen atoms attached. Hydrogen is so easy to handle. It has only 1 electron, and phosphorus will contribute another electron. Don't forget, phosphorus had 2 extra electrons. That's 5 electrons. So this is how the total cross diagram goes. And the labor. Okay, no? So let's go to the next page. Anyone needs more time? Right, next one. Then make a discussion. Describe 2 ways in which properties of ammonia are different from those of phosphine. So here phosphine, it's a gas at room temperature. Let's write what you know about ammonia here. Can you remember ammonia is also what? It's also a gas, right? How do we know? We did that in gas testing, right? Ammonia, gas color tested, Haber process, it was produced as a gas. So then you nobody takes it as a gas unless you cool it and condense it, right? Ammonia is very soluble gas. It's a very soluble gas. That's why in order to get ammonia out of that solution, you have to heat. Otherwise, it doesn't come out from the solution. And it reacts with hydrogen chloride. Yes, we learn ammonia reacts with HCl to give that white smoke. We did that in the diffusion experiment. No effect on litmus paper phosphine, but this is going to turn red litmus what? Blue. Right? Decomposes to hydrogen and phosphorus only when warmed gently. Ammonia decompose at higher temperatures like in the Haber process. So then they ask in 2 ways. We can already see 2 good examples. Ammonia is soluble and it turns red litmus blue because ammonia is well-known basic compound. This is a well-known basic compound. We know that that's what we treat as weak base in our syllabus. Ammonia is the weak base in our syllabus. So then they have given ammonia is soluble, ammonia turns red litmus blue, ammonia doesn't decompose, right? And describe and explain the difference in the rate of diffusion of gases, ammonia and phosphine at the same temperature. Describe and, right, all right, so then you have to basically find the molar mass. Ammonia is 17, phosphine is phosphorus, if you check, it's 31. Therefore, this is going to be 34. So phosphine is heavier than ammonia. It's like twice as heavy as ammonia. So definitely diffuse slowly, right? Slowly. So any of these 2 arguments will be accepted, right? So if you can show the values, then it might give you a better chance of getting full marks. And it burns oxygen to give phosphorus peroxide. Phosphorus 5 oxide is an acidic base. Atmospheric give the reason. without any doubt, you are going to straight away say it's acidic. Okay, it's a non-metal oxides, right? As oxides are acidic when they are non-metallic. But if I ask the question the other way around, if I ask the question other way around, are all non-metallic oxides are acidic? No. Why do you say no? No කියන්නේ මම ප්‍රශ්නය අහපු විදියටද නැත්නම් හරි දැනගෙන? Yeah? Why you say no? Sorry? හා? අහපු විදියට no කියනවා. එහෙම නෙමෙයි. ඒ වෙලාවට process කරන්න ඕනේ. ඒක තමයි ඕගලන්ගේ දැන් ටිකක් හොඳයි. නෑ ඕගලන්ගේ තාම grade 9 ලා අපි තාම analyze කරේ නෑනේ නම. Like I'm wondering how these guys are going to show the may understanding level. ඕගලන්ගේ batch එකට තියෙන ලොකුම issue එක ගොඩාක් අය information process කරන්නේ නැහැ mind එකේ. අනිත් එක ලේසියෙන්ම framing bias කරන්න පුළුවන් කිසි කරදරයක් නැහැ. Framing bias කියන්නේ ගාන්න information ටික දුන්න ගමන් the way that I want you guys to think, then I can get your thinking change according to what I want. Right? I mean, not in the education, right? That's because you guys are the one of the most affected batches due to the online, right? අපි ඒක overcome කරන්න ඕන ළමයි, right? We have to let our brain to process information, right? අපි process කරන්න මේ information. You guys like process information. අර process food කියලා තියෙන්නේ. අපි හරි ආසයි process food කන්න. අපි උයාගෙන කන්නේ නැහැනේ. ඇයි? අපි ආස උයලා තියෙනවා කන්න. නේද? pizza ගෙනල්ලා කනවා නම් snacks කනවා නම් process food. Right? දැන් මේ online case එකෙන් ඔයගලන්ටත් වෙලා තියෙන්නේ they give you process information. Process information එක දුන්නාම you are happy. Ammonia is basic, it turns the litmus blue, right? And then they ask another question. Can ammonia react with acid? And they may what you know ammonia is basic, right? You get my point. But if they give you a non-processed information like this phosphate, you're lost. Aluth information compare the process කරන්න බෑ. අපි ටික බලමුවා. I'm not only preaching about this. I usually include such questions in order to improve your thinking. Okay, so then acidic. Now I ask, are all acidic oxides non-metal oxides? Are all acidic oxide non-metal oxides? Ekat no. That's also not. Right? Eka syllabus එකේ නැහැ. Okay. Are non-metal oxides acidic? You are non-metal oxide. මම අහන ප්‍රශ්නේ yes the no ද කියන්නකො. Yes the no ද කියන්න. හරිද? Are non-metal ඉන්නවා පොඩ්ඩක්. මේ බලයි ලියන්න ලියන මාත්‍යා වගේ ගමේ ඉන්න. හරිද? Are non-metal oxides usually acidic?
Yes. Yes.
Okay. Second statement. Are acidic oxides okay. Are acidic oxides are always non-metal oxides?
No.
Are acidic oxides always non-metal oxides? ඒක තමයි කලින් කිව්වේ. Right? No. Why? Because I said no earlier. Not because you know it. All right. Okay, next one. Are all non-metal oxides acidic? Aren't all non-metal oxides acidic?
Yes. No.
දැන් එහෙම ආවම yes කියයි. හරිද? දැන් කොහොමද yes කියයි. What's your answer? Aren't all non-metal oxides acidic? Let's say not all non-metal oxides acidic. Why? Example. Carbon dioxide is acidic. Carbon monoxide. Carbon monoxide is an oxide of non-metal, but carbon monoxide is considered as what? Neutral. Right. Next question. Are all metal oxides basic? are all metal oxides basic? No? Metal oxides basic ne? Aneka naya. Okko mademi. Very good lamai. And this is what I want you guys to develop in thinking. Manusya ප්‍රශ්න අහන විදිහට රැවටෙන්න එපා. Information දෙන විදිහට රැවටෙන්න එපා. උඩ රැවටෙනවා. Right? Right? When I ask, aren't all non-metal oxides basic? ඉරෙවම ටිකක් upset වෙන්නේ. මම are all metal oxides basic? ඒවා ගන්න මෙයා අහන්නේ නිකන් game එකකුත් නෑ වගේ. Right? Don't ask. So you process. There are some metal oxides, they are not basic. Give me an example. Amphoteric oxides like metal oxides from amphoteric metals. Amphoteric metals but oxide is amphoteric. You can't say it is basic, right? ඒ වගේ පොඩි පොඩි කචල් තියෙනවා කල්පනාවෙන් කරන්න. හරි ලියාගන්න. Okay, next question. Enough time. Explain the meaning of the term weak acid. 1 marks, therefore, you need to give partially dissociate. Doesn't completely ionize. I don't like that ionize word, but it's all right. No, not less. When you say less, it sounds like concentration is also less. I mean, concentration of acid less, then you get less H plus. So it's always another good way you can write reversible dissociation. If you have written the reversible dissociation, then put wrong. No. It should be correct. Reversible dissociation, right? The acid dissociate reversible, right? The pH of an aqueous solution of sulfamic acid, then sulfamic acid එක අහලවත් නෑ ළමයි. එහෙම තමයි exam එකේ questions then. They will give you an acid that you haven't even heard about, but they have given you it's a weak acid. Then you can go through the weak acid properties, right? ගොඩක් අය බයයි මේ අලුත් නම් ආවම බයයි, right? In your biology, you don't have this problem. Why? Right? Biology, if you have some certain types of organs in the body, they are the ones coming to the exam. They never ask a different organ. So then you are kind of what? And the question is asked, you are familiar. Right? Now, if they are going to ask about the heart, it's going to be about the heart and its valves and heart and all this. Heart there is a special feature in the heart and there is some kind of lungs inside the heart. That's the case. The biology or the physics, same scenario, right? Whatever it is, it's most of the time. If it is motion, it's going to be like motion equations, right? If it is like mechanism, electric field, so that they are very defined, confined. This is why chemistry is hard. Chemistry is a ප්‍රශ්නේ, right? They are sulfuric acid. You get scared, but you don't. One reason you don't read the next. Now, listen, sulfuric acid is a weak acid used to remove lime scale in kettles. Now, lime scale. Lime scale because you haven't even seen a kettle where some lime scale inside. Do you know what lime scale is? Now, if you look at some villages, like not in the town, even in the town, some kettles at the bottom or even in the coil, there is like whitish layer is a solid is deposited. That's calcium carbonate because water contains calcium and hydrogen carbonate ions and calcium carbonate deposit. Right? Then the kettle you will have like that's white deposit. So then sulfuric acid and then lime scale, double shock. I think Banaban in also again with the revision again, right? That's what you're thinking. Right? No, they are giving you some new words, but concept is the same, weak acid. So you write that answer. Then they ask pH of an aqueous solution of sulfuric acid can be determined using pH meter. Right? This is not a new thing, right? You can measure the pH of weak acid. Describe another way. All right. You need to know what's the pH of sulfuric acid. In order to do that, we are going to use pH strip, right? You can use pH paper. pH paper is one way. Don't write red litmus or blue litmus. Red litmus, blue litmus, they do not tell what. Why can't we use red litmus or blue litmus? Why? No pH. Okay, not bad. You tried something. Why can't we use red litmus or blue litmus? They don't tell you what's the pH is. They will tell us acidic or basic, but not the pH. Therefore, you need to have a pH paper. In the pH paper, you will have like color circle in the bottle and give some colors and say, okay, if this color is there, that's pH 4, 5, 6, 7. They will tell the color circle will give us, right? Or you can use universal indicator because when you put universal indicator, right? Universal indicator has a color code, color chart. Color chart එක අපි දන්නවනේ universal indicator දන්නේ. Universal indicator එකේ color chart එක දන්නවද නේද? Right? ඒක දැනගන්න ඕනේ 1, 1, 2, 3, 4, 5, 6, 7. Below 7, they all are acidic colors. Right? These 1 to 2 red. After that, it becomes orange. And after that, it becomes yellow. And on the dot 7, it's going to be what? Green. Right? So, yellow, exam begins, yellow green. Yellow green can yellow green nothing beneath. Intelligence yellow green means something in between what? 6 and 7. So it's very close to 7. Right? So that's likewise you need to have indication of color. So it's universal indicator or pH paper. There you have to check with what? Color code or color card. Match the colors against the color chart. That's how you measure them. All right. Next one. Sulfuric acid mass is given. Mass is given. And it dissolves in 25. Okay, mass doesn't have to deal with concentration straight away. Anyway, the sulfuric acid requires this amount of potassium oxide for the complete neutralization. Oh, that's a good question. That's a good question. Calculate the number of moles of sulfuric acid that react with 1 mole of potassium hydroxide. Okay, first of all, my question is on the target. In this, they have given mass of sulfuric acid. That means you can straight away find it moles. What's the equation? MO over capital A. They have given the volume as well as the concentration of potassium hydroxide. Therefore, you can find the moles using N equals CV. N equals CV. The concentration C. This is the V. And you have the 2 moles. Right? What about these 2 moles? Sulfuric acid moles and KOH moles. Are they, what's the ratio between them? What's the ratio between them? Values are they very close or not?
Close.
Close. That means 1 mole of KOH reacts with what? 1 mole of sulfuric acid. Right? So that's what they ask. Number of moles of sulfuric acid reacts with 1 mole of sodium hydroxide is 1 mole. Right? Okay. Just write that down before I explain the rest. It will overload the information. Now don't write answer D and E. I will explain. Sharp at 7, I will give you the paper. Whether I'm going to finish this discussion or not, I will be giving the paper. Full papers, දෙකක්වත් කරන්න ඕනේ නැත්නම් the plan is this, like today we'll do full paper, next day we'll discuss 1 hour full paper, discuss 1 hour full paper, and then have another day. Week after next, then we can discuss both the papers together, the remaining of the first paper and the right. We'll try.
Okay.
Well, revision දවසක paper එකක් කරේ නැත්නම් වැඩක් නෑ අපිට. ඒකයි දේශ. Okay, aqueous sulfuric acid reacts with magnesium to form magnesium sulfamate. By sulfamate formula එකක් දීලා තියෙනවා. You just have to write the equation. So then SO3 NH3, that's sulfuric acid, reacts with magnesium, giving you magnesium sulfamate NH2 twice plus, so you know acid and metal give you what? Acid and metal මොනවද දෙන්නේ හැමතිස්සෙම? Metal and acid reaction, what do they give? Salt and metal and acid මොනවද දෙන්නේ? Metal acid. The metal acid කියලා ගොම ඊතර මොකක්ද දාන්න? Magnesium and HCl. It give you what? Salt and hydrogen. Water දෙන්නේ. Right? Metal now, water දෙන්නේ. Metal oxide now, තමයි water දෙන්නේ. At least you gave an answer. That's good. Right? So you get what? Hydrogen. And in order to balance, you can see there are 2 sulfamate needed. Therefore, you need 2 sulfuric acid. That's how you balance. Lime scale, calcium carbonate. You know calcium carbonate reacts with acids. Right? Think කලබල වෙන්නේ නැතුව ළමයි. ඔයා දන්න products දෙක ලියන්න. Carbon dioxide and water. Carbonate reacts with acid to give carbon dioxide and water. ඒක definitely then on it. Then salt එක තමයි ලියාගන්න. Anyway, it's going to react with sulfuric acid. මේ පැත්ත ඔන්න you just manage. Then කොහොමද salt එක ලියන්නේ? Look at the salt. Look, they have given the formula of magnesium sulfamate. The magnesium and calcium both are same in the group. So you write it as it is. Remove magnesium, put calcium, and write the formula. Right? Write like this. Twice. So you need again 2 sulfuric acid. And it reacts with NaNO2 to form water, sodium, hydrogen, and colorless gas. Suggests the identity of colorless gas. Now you know it's nitrogen. ඔයාලා දන්නවා දැන් මේකේ ලියලා තියෙන ඉඳන් nitrogen කියලා දන්න. හැබැයි ඔක ගන්න දැන් ලියන්න එපා කරලා. Stop writing this. But you don't know how to get it. This is again not in the theory. This is a question where a lot of AO2 marks allocated. Product AO2 තියෙන. මේකේ දැන් ඔයාලට මේ answer එක පේන හින්දා nitrogen තමයි answer එක. එහෙම නෙමෙයි මේක ගන්න කොහොමද? How do we get this is nitrogen? So what you do, you just follow information they have given. Sulfuric acid, SO3NH3, right? With sodium nitrite, NaNO2, right? And it's going to give you sodium hydrogen sulfate, right? And another colorless gas. So up to this they have given. So then what you can do here, we can look at the number of atoms and the elements found in reactants and products. Sodium is here. You have sodium, right? Sulfur and 3 oxygens. Sulfur and 4 oxygens are there, right? And the 2 nitrogen atoms are missing. two nitrogen atoms are missing. Water water product right? So then 5 oxygens here, 5 oxygens. The number of hydrogens also tally. 3 hydrogens, 3 hydrogens. So what is only missing? 2 nitrogen atoms. එහෙනම් මේ product එක ඇතුලේ unknown product එක ඇතුලේ මොකද්ද තියෙන්න ඕනේ? 2 nitrogen atoms. So then you have N2. If you believe that you can do, then you really can do this. හැබැයි වා information process කරන්න නැතුව අනේ මන් දන්නේ මේ මොගුල මට තේරෙන්නේ නැහැ කියලා හිටියොත් කිසිම උත්තරයක් ගන්න බෑ. Right? But you can do. ඔයා දන්න පොඩි දෙයින් answers ගන්න පුළුවන්. හරි. එයාගෙන කන්ට there is lot to write. හරියට. The thing is, we don't know the valency of hydrogen sulfide, but you can find it. However, they have given the formula. Formula එක තමයි කියන්නේ අපි information බලන්න ඕනේ. Information දීලා තියෙනවා යා. Kind of a difficult question, right? Think about how nitrogen came into the picture. Right, next one. Nitric acid is used to make soluble salt potassium nitrate. Name the alkali which you need to react to get potassium nitrate. Nitric acid, you are going to produce potassium nitrate. And alkali alkalis are group 1 hydroxides and some group 2 hydroxides as well. Therefore, the answer is potassium hydroxide. Experimental procedure used to make colorless aqueous potassium nitrate from alkali and nitrate. You use the titration method. Why? We applied that concept last day, right? Potassium hydroxide is a soluble base and potassium nitrate is a soluble salt. So you can either titrate nitric by potassium hydroxide or other way around, titrate potassium hydroxide by nitric acid. So then titrating 2 marks, right? But when you titrate, you need to use what? An indicator to find the endpoint, right? And in salt preparation, once the now for example, you take 25 cm cube here, you titrate by putting phenolphthalein, color change will happen. Color change is nitric to potassium hydroxide is colorless to pink. Colorless to pink. And then you can find out the volume here. Suppose the volume is 20, just assume. And you are going to repeat the experiment with 20 cm cube without the indicator for salt. That's the way. Write it down. If there are any things to clarify, you can ask. All right, let me go to the next one. Aluminium is manufactured by electrolysis. Now, aluminium extraction we did so many times. So the oxidation reaction, positive electrode oxide become oxygen and 4 electrons. Negative electrode cation, the aluminium 3 plus. Those things you know now, right? And explain why aluminium doesn't corrode most in moist air. This aluminium oxide layer on the surface, you have to say it's impermeable, or the layer will not let oxygen to reach surface. Layer will not flake off. That's another very important thing. If they ask why iron also form oxide, aluminium also form oxide, but iron corrodes, aluminium doesn't. Okay, behind what they can ask. Aluminium also forms oxide, iron also forms oxide, but iron corrodes, aluminium not. The reason you have seen when the rusting happens, those oxides can be taken off like flakes, flake off current. But iron, aluminium oxide, right? With these aluminium strips, they are anodized. That means oxide layer is good. You can't break off it. Therefore, it sticks to the surface and stop further reactions. Okay. Why iron is corroded but not aluminium? Here. Aluminium. It's iron oxide aluminium oxide but aluminium is protected, but iron not. It's corroded. Why? Why? Iron oxide and more than turn into breaks and you can right? Actively underground iron pipes rust easily. This can be prevented by magnesium. This I have explained it many times, but let me explain it again. So when iron is going to give electrons to oxygen in air, right? When we connect this with more reactive magnesium, right? Magnesium doesn't like iron is getting oxidized because this is more reactive, right? This is more reactive. So then magnesium will quickly send that electrons to iron. Okay, you give the electrons, but don't get oxidized. I am the one going to get oxidized. So you call it sacrificial protection. Magnesium send electrons to iron to give that to the oxygen. But you don't have to write all these things. Explain these forms, how this form of rust prevention, explain this form of rust prevention, you call it sacrificial protection, right? And you say magnesium gets oxidized preferentially over iron because it is more reactive, right? Look at the Marxian answer. Magnesium is more reactive, is oxidized more easily. Magnesium reacts instead of iron because it is more reactive than iron, right? See whether you have written the answer. And this is a soluble salt. I told you, then this should be titration method. This should be titration method or excess solid method. Titration method or excess solid method. Excess solid method. And if you are going to make aluminium sulfate, then you have to think about definitely sulfuric acid. Like sulfate and sulfuric acid again. Then from aluminium, it should be something like aluminium hydroxide. Aluminium hydroxide is insoluble, or aluminium is insoluble, or you can react aluminium carbonate, anything, or aluminium oxide, insoluble. So you have to use excess solid method. The use of aluminium oxide or aluminium carbonate or aluminium, and then sulfuric acid should be, and then filter off the excess aluminium, and then crystallize, filter, wash and dry the crystals, right? So that's how you make the
Part of outside,
yeah, you use mark because it's very important. Excess solid method they're gonna You have to say that you are using excess insoluble metals for a base. It's all preparation. I mean, revision class is some other questions that come along. I don't know this. Okay, it's not that you don't know, you haven't studied that. Therefore, you go home and study on the particular topic. Right? Revision class එක අද කරා මෙතන ඉවර නෑ. ඊට පස්සේ ඔයාලා ගෙදර ගිහලා කරන්න වැඩ තියෙනවා ඒක. Right? Any question? Yeah. Come on. Aluminium hydroxide. Go ahead. Then the plan. Okay. Any more inquiries? All right. So let's go to the next question. Question number 6. Which page are we now? Page number 7. All right. Okay. Describe how explain why water can be separated from aqueous copper sulfate by distillation. You may draw a label diagram. The reason is copper sulfate. Copper sulfate is a soluble salt. Copper sulfate is a soluble salt, but it is not volatile. It is not volatile because it's ionic. But water is volatile. So we distill this off. Right? We have the distillation or adapter. And we put the thermometer over here. And condenser. As far as the water enters from the bottom part, that's enough. And then this is the receiving flux. Right? So you may draw a label diagram. Let's say it depends on boiling point. Copper sulfate has high boiling point, non-volatile or high boiling point because it's ionic. High boiling point. And water is volatile. It has lower boiling point. That's why you can evaporate it. And then the correct apparatus and the flask has to be heated or make a heat karna on mark. And water evaporate, you have to explain it water evaporates. Water vapor converted to liquid, that means condenser. This is water in and water out. Water out, that's condensing. I mean cooling. And this is distilled water. This is called distilled water. So any acceptable points are taken. How many marks? 3 marks. So then any 3 points, you can get 3 marks. Especially you have to mention that the boiling point of water is much less than copper sulfate. That's important. Otherwise, you don't know whether copper sulfate is also coming. But how do you know copper sulfate has high boiling point? How do you know that? Ionic compound. You asked that day also, right? Okay, ionic compound. Copper sulfate is ionic, so it doesn't boil up. Volatile is evaporating. So non-volatile is the opposite. Not easily operating. Right. What method is used to separate excess copper oxide? It is insoluble, therefore what? Filtration. All right, so we'll go to the last page also. Just give me a second. Want to have a look at. Right here. Paper chromatography is something very easy, right? Why should the baseline should be in pencil, not ink? Because ink is going to get separated or it's soluble. And when the separation of amino acid is complete, chromatography paper sprayed with locating agent because amino acids are not colored. They are not visible. So to have them visible. And how to find the RF value, you need to measure the distance over here. This is called distance traveled by the solvent front. You have to measure that, right? And they are asking the spot of S the name. Right. So then you measure the distance traveled by S. So let me call it ds. Then it's ds over dsm. So they are saying it's approximately 0.71. So you get a range, right? Measure listen now. When you measure it, you have to show it. You can make a key is it 5? Is it 5 cm? Right? And this is going to be like, let's say 3.55 cm. You have to show it. So, then only, even though you go wrong in this, they can consider whether we are going to give the mark if you have done it correct. Because the answer is well away from the real value, right? And your working is not also shown, then it's difficult to give the mark, right? All right, so here, are we done? Super. Okay, so let's go to the paper. You have like 3 to 4 minutes to just settle down your mind and get ready for a long paper. Because good price. Correct. Thank you. We will start at 7:05. Okay, so shall we do a small adjustment in your places? Jennifer, can you move or yeah, at the back and this will be the how the Sierra carburetor and mixer iron. Online students, your paper is on. You can download it and get ready. We will give you like a few minutes for that, 5 minutes, of course. Okay, this is kind of a long way for you guys, no? I'll give you the periodic table. Online students, put your videos on and 705. और एक ट्यूटर का टाइम करना है। नहीं बैटरी का तो बता दें। You must write the answers. You must write the answers using pen, not pencil. All right. Okay, you will be given 1 hour and 40 minutes, not 45 minutes. Because we reduce the marks to 75, not 80. Online students, make sure your video is on.